Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be continuing our discussion on factoring polynomials, in particular, how we go about and determining what two polynomials multiplied together to give us a given polynomial. This time we're going to be learning about a technique called the trial and error method, or more specifically, we're going to refer to this as using the box method for factoring. We're going to start by looking at factoring sizes, meaning if you multiply various polynomials of different sizes together, how many terms do you generally get for their solutions? Then we're going to use this idea to help remind ourselves of the work that we would do with box method multiplication to hopefully reverse it and come up with factors. So first let's talk about factoring sizes. Let's review what would happen if I multiply different sized polynomials together and what their sized answers might be. Remember, anytime you multiply a polynomial and another polynomial, your answer will be a polynomial. This is closure under multiplication. We've talked about this before, that anytime you multiply or add or subtract two polynomials, your answer is always going to be a polynomial. So let's start by saying, what would happen if I had a monomial times a monomial? A single term polynomial, like 2x to the third, times another single term polynomial. Well, we would end up with another single term polynomial. So a monomial times a monomial is in fact a monomial. And we should expect that. If you have one term and another term, they just multiply together to give you a new term, okay? Now let's try to see what would happen if we took a monomial and we multiplied that by a binomial, a two-term. So let's say I had 2x cubed times 5x plus 1. This would give us a 10x to the fourth plus a 2x cubed, or a binomial. So a binomial and a monomial, we just would distribute the monomial through and end up with a binomial. And the same thing we could say for a monomial and a trinomial. We should just end up with a trinomial, because anytime we multiply a monomial by a polynomial, we're just distributing it through, okay? So a monomial times a monomial is a monomial. Monomial times bi is a binomial. And a monomial times a trinomial is a trinomial. All right, that should make sense. Now let's talk about larger sized multiplication. Let's try a binomial times a binomial. In this situation, we are going to take a two-term polynomial like 2x plus 1 and another two-term like 3x squared plus 5. We would end up with a four-term polynomial. This was something we saw in our discussion on grouping. When we had four-term polynomials, they factored down into two binomials. Four terms were made up when I had two binomials multiplied together to give us four terms. You can think back to when we would use the box method or foiling. Anytime we would use the box method, and we would multiply things together, two binomials together, we would end up with 1, 2, 3, 4 terms. So binomial times a binomial will give us a four-term polynomial. Now let's take a look at when we have a binomial times a trinomial. Well, in this case, if I did the box method for a binomial, and then I had three terms for a trinomial, we would end up with 1, 2, 3, 4, 5, 6 terms. Hopefully you're starting to see that the size of one polynomial times the size of the other polynomial, I'll call them polynomial 1 and polynomial 2, gets you the size of the new polynomial, okay? If I'm taking a trinomial times a trinomial, I would end up with 9 terms. If I took a trinomial times a 4-term polynomial, I'd end up with 12 terms. Really, all that we're doing is we're multiplying the sizes together. Okay, so what could our possible answers be? Monomials, binomials, trinomials, 4-term, 5-term, 6-term, etc. So, actually, they go 4-term, then 6-term, and then we would just keep going with our multiplication from there. Let's take a look at an example of a trinomial. What could multiply together to get us a trinomial? Well, in our previous discussion, we said we could have gotten a trinomial by multiplying a monomial and a trinomial together. So maybe this is one thing. Maybe there's just one term that we've multiplied by, and then this would be a trinomial. Well, hold on. When would that work? A monomial times a trinomial, that would basically be a GCF. That's the situation when I'm multiplying by a monomial. I'm multiplying a GCF by a trinomial to get this. I would be distributing it through. But is there a GCF in here? Actually, no, there isn't. There is no GCF for x squared, 7x, and 12. So this idea of multiplying a monomial and a trinomial together doesn't work. So we need a new set of sized polynomials to work with this. Okay, well, what other sizes could we have? We said before a monomial times a monomial got us a single term monomial. Monomial times binomial got us a binomial. A monomial and a trinomial got us what we wanted, a trinomial. But that didn't work in this particular problem. We said because there's no GCF, there's no monomial that we've distributed through to get this. So this one didn't work. Then we said, okay, any other increased one wouldn't work. So let's try binomials. Binomial times a binomial. Uh-oh, that was a 4-term. Shoot. And then if I just keep increasing, binomial times a trinomial, that got us a 6-term. Oh no, how do we get a trinomial then? Is this truly the only way of multiplying two things and getting a trinomial together? Well, hopefully you're saying, no, that's not the only way. Think back to what we did with polynomial algebra. When we would go and we would multiply together two polynomials, oftentimes we ended up with a trinomial as our answer. But under what circumstances? Let's flip back to this page. Notice that when I take two binomials, we end up with a 4-term polynomial because we have 1, 2, 3, 4 boxes to fill. But wait a minute, what did we say was unique about the box method? What would often happen in the box method case? Hopefully you're saying, generally, these were like terms. Like terms were diagonal from each other. If we multiplied two binomials that had like terms, they would combine together to make a trinomial. That was really the only other case, right? If I had a binomial and a trinomial, then we said we could get a 6-term polynomial, or these could be like terms, and we could end up with a 4-term. So you could have a 6-term, or if there are like terms in there, you could have at least as low as a 4-term. So let's go back to this problem. How do we get a trinomial? What are the only ways? Well, you could have multiplied a monomial times a trinomial, and we said that didn't work. We already checked this. There's no GCF, so it's not going to work. The only other way to get a trinomial is if you had a binomial times a binomial with like terms. That was the only other situation. So we hope that what we have done here is multiplied two binomials together and had them contain like terms. So let's try that out. So here are the two values for the binomials. We don't know what they are. They're a mystery to us. But we know that when I multiplied these first values, we got an x squared. When we multiplied these last values, we got a 12. And then these terms, these middle components, must have been like terms that add to 7x. So let's try to go through and perform this multiplication and see what we can come up with. So I reworked the box a little bit here so we can use some color to see what's going on. We understand that we are going to try to multiply the first components in each binomial to get an x squared, and the last components to get us a 12, and these middle boxes are going to add together to get us the 7x. So the first thing we need to do is identify what times what got us x squared. Hopefully you're saying that x times x got you x squared. That must have been the first thing in each of the binomials, because how do we get an x squared? Well, x times x. Then you have to say to yourself, what times what got us 12? Here's where it gets a little more difficult. We could say things like 2 times 6 got us 12. Or we could say 3 times 4 got us 12. Or we could even say 1 times 12 got us 12. But don't forget, we also have negative possibilities. We could even have -1 and -12 gave us 12. Or we could have had -3 and -4, or -6 and -2. The point is there are a lot of possibilities for things that we could have that multiply to give us 12. How do we know which one is the correct one? Well, it all comes down to the 7x. What we're saying is that whatever we decide to put in here for the binomial, whatever we decide to multiply to get us 12, we also have to make sure that those things add together to get us 7x. So what two numbers multiply to get us 12 but add to give us 7x? 3 and 4. Because we would end up with a 4x and a 3x. So in our final answer, we would have an x squared plus a 4x plus a 3x plus a 12. This normally would be a 4-term polynomial, but we have like terms. So our final answer is going to be an x squared plus 7x plus 12. We've gone through and we've found what things multiplied together to get us this. So those factors are x plus 3 and x plus 4. The idea with this is we're using the box method and some logic around it to carefully pick what numbers we want to factor down these individual components. So let's remind ourselves of the process that we just used for going ahead and breaking this down. First up, we are going to construct a box for the box method. The first term of the polynomial is in the top left box. That would be this one. And then the last term of the polynomial is in the bottom right box. That would be this box right here. We can say that we need to identify what multiplied to get us these values. So identify what multiplied to get us these values, the x squared and the 12, but also added to get the middle value. That's a key idea here. We really need to show that not only are you determining what multiplied to get you the values, but what also added to get the middle term. That's what you need to do when choosing these components. When you're deciding what multiplied to get you these values, you're also saying what added together to get you 7x. Again, let's practice this idea using the box method a little more so we can really see what's going on in our decision making. First up, let's try one practice problem together, and then let's try to formally define when we're going to go about using this technique. So we start by constructing a box. And I like to use color coding whenever I do this. So I'm going to say I must have multiplied some things together to get x squared. And I also must have multiplied some things together to get 30. But whatever I chose to multiply to give me 30, those values must have added together to get me 11x. Because on the diagonal is where like terms occur in box method. So let's go through and let's see if we can choose what components multiplied to give us these values. So first up, what multiplied together to give us x squared? Hopefully you're saying right away that it's x and x. Those are the two quantities that multiplied together to give us x squared. The next thing is what multiplied together to get us 30? Well, we have several choices, 3 and 10, 5 and 6, 1 and 30, right? But we need to pick the values that added to give us positive 11x. Well, if you're in doubt, just go ahead and list the factors of 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. And then don't forget the negative factors as well. -1 and -30, -2 and -15, -3 and -10, -5 and -6. Which of these adds up to 11? Well, notice that the 5 and the 6 do. So we could have 5 and 6 to give us 30, but we can also show that when we multiply in the box method, we get a 6x and a 5x to make 11x. So our final answer, our factors for x squared plus 11x plus 30 are going to be an x plus 6 and an x plus 5. We've gone through and we've shown that these multiply to give us the terms that we want and add to give us the value that we want. Now, when do we go about using this box method? when is the purpose of this technique that we're using? Well, we can say that we're going to use box method when factoring trinomials. This will be a large portion of the factoring that we're doing in this course and in future courses. When we're going to factor down trinomials, we are going to get these two binomials. So that's the idea of factoring with box method. Now, there's a specific note that we need to put in here for when we can use this. We are factoring using the box method, or as the book sometimes refers to it as the trial and error method, when we're factoring trinomials, but notice that all of the trinomials we factor have a leading coefficient of 1. Take a look at some of the previous problems, right? Leading coefficient of 1, leading coefficient of 1. In these problems, it was very easy to decide what times what got us x squared. X times x, right? Very straightforward, very simple. This is going to become very difficult when the leading coefficient isn't 1, and we're going to have another technique for that. So we'll say to ourselves, when you're factoring a trinomial, you can use this box method, but only when the leading coefficient is 1, okay? This is going to be the general method, or I should say the general requirement we're going to use for when deciding to factor trinomials with this box method. We'll see in a future video how the box method works when the leading coefficient isn't 1, and how really it gets a little more messy, but we're going to come up with another technique for doing this, okay? So right now, if we remind ourselves from previous videos, we have the GCF method, which works for any size polynomial. We have the method of grouping, which works for 4-term polynomials. We have the method of the box method, which is used for trinomials, or 4-term polynomials that have like terms. Let's see if we can keep coming up with other techniques that help us break these values down. Right now, though, let's go ahead and let's keep practicing the box method. Let's make sure we're comfortable with solving these practice problems. Pause the video, take a couple minutes, and when we come back, we'll see how I constructed the boxes and how I use them to determine our final factors. First up, hopefully you're able to construct your boxes. I wanted to take a minute to show you how I went through and constructed each box, how I'm placing all of the first terms in the top left box, and all of the last terms in the bottom right box. One of the things I also want you to notice is the signs I'm including. In particular, for the last problem, I've said that the last term we should get is the negative 24. I've included this sign along with that. That's important. Because really, when we multiply things, I'm saying I want to end up with a negative 24. Also, I've included the signs for when we add things together. Okay, I want a negative 9x here, for example. That's important because when I choose what things to add together, I want to end up with a negative. So signs are important here. Make sure you include them in the boxes and when deciding what to multiply or add together. I'm going to take another break and let's make sure we have our boxes set up, and then let's make sure we're going through and selecting each term that we want. All right, pause the video, see if you can get the term selected, and let's see if you can decide how to factor these trinomials down. All right, well, as you go through these box method problems, hopefully you're going through and selecting the appropriate values for each of these. Things that have to multiply to give you the last term, but add to give you the middle term. So in this case, we had what multiplied by what got us 21, but add to give us 10. I chose 3 and 7. And then in the next problem, what multiplied to give us 81, but add to give us 18. I chose 9 and 9. And then in the next one is the first time we see that we want things that multiply to give us positive 14, but add to give us negative 9. So what multiplied to give us a positive number, Well, those could be two positives or two negatives, but if they have to add to give us a negative number, they better be both negatives. So I picked -7 and -2. Then for the last one, a little more tricky, I need things that multiply to give us -24, but I also want them to add to give us a +5. Well, how can I multiply two things to get a negative number? Well, one of them can be positive and one of them can be negative. And then if I want to get a positive number for my answer, I better make sure the bigger one is in fact the thing that is positive. So in all of these problems, hopefully you're seeing that the factors are x plus 3 and x plus 7, x plus 9 and x plus 9, x minus 7 times x minus 2, and x plus 8 times x minus 3. These are essentially the quantities that we're working with here to factor down or to break down the polynomials. Again, as I said, you'll notice that all of these polynomials have a leading coefficient of 1. There's not much decision making when figuring out what times what gets you x squared. In the next video, we're going to explore what happens when the leading term is no longer a 1, but something more complicated, a little more elaborate. And we're going to need another technique for breaking those down. If you have any questions or comments about the video, please let me know. My email is klinford, that's KLINFORD, @wccnet.edu. Until next time, take care.